Hi, today we are going to look at our third section here, 2.3, Applying Deductive Reasoning. Earlier in the unit, we talked about inductive reasoning. So deductive is, I guess you could say it's the opposite, but it's just another type of reasoning. So we're going to define it, identify whether a situation is inductive or deductive, and then there are two laws of logic that we're going to study. So, deductive reasoning, starting off with a definition. Deductive reasoning is using facts, definitions, accepted properties. Okay, using facts, comma, definitions, accepted properties. Any of our postulates or theorems would be considered acceptable. Facts, definitions, accepted properties, and laws of logic to form arguments. And laws of logic to form arguments. Okay, so the process of deductive reasoning is using facts, definitions, accepted properties, you could throw postulates, theorems, those types of things, and laws of logic to form arguments. So the main difference between deductive and inductive is deductive, you have some sort of fact definition, maybe it's like a procedure in place. You know, think about a school. If you have certain rules in place and you make a decision based on the rule, that's deductive reasoning. Inductive reasoning, if you want to flip back a couple of pages, is when we looked at a pattern. We looked to see, did something occur multiple times? And if it did, then we formed our, I guess argument's the wrong word, we formed our idea based on what we previously had observed. Okay, so if you could sort of sum up inductive in one word, I'd say pattern, and then deductive in one word, I would say maybe facts or definitions. Okay, so what I'd like you to do, I want you to pause the video, and I'd like you to, for A, B, C, and D, read the sentence, and I want you to write down, do you think that the conclusion reached is based on an inductive reasoning pattern, or an inductive reasoning idea, so is it a pattern, or is it deductive reasoning, is it more factual and definition-based? So, stop the video, go through these four, and then come back and we'll talk about them. Okay, number one, or letter A. The rain stopped, the sun came out, then next a rainbow will appear. So this is an inductive idea. Shouldn't say idea, inductive reasoning. So when you previously have experienced it raining while the sun was out, or maybe the sun comes out right after it rains, we tend to see a rainbow. We don't always see a rainbow when that occurs, but that's usually based on a pattern of observation. Second one, Jose put $25 into savings each week for 10 weeks. Therefore, Jose has put $250 into savings during this period. This is deductive. You can mathematically figure this out. So anytime you're using math, formulas, equations, that would fall under a deductive reasoning idea. Okay, quadrilateral ABCD is a rectangle. All rectangles are parallelograms. So quadrilateral ABCD is a parallelogram. So this is deductive. All rectangles are parallelograms is a definition or a fact in math. So the conclusion is drawn that because of that, you have a parallelogram. So this is deductive. And then finally, Ken has eaten a peanut butter sandwich every day this week for lunch. Tomorrow, Ken is going to eat a peanut butter sandwich. This is inductive. Because we can assume that he's been doing it, we think he will do it, that would be inductive. Okay, so patterns, observations, those go with inductive. More factual evidence goes with deductive. Okay, I'm actually going to come back to this box because I have this a little out of order. So let's go on to the next example, and we're going to practice a little bit of what we did in the last section. Okay, so we'll come back to those laws of logic. All right, let's work on, notice the notation, P's and Q's, contrapositive inverse. Let's work on that a little bit more. Okay, let P be a number divisible by 3. So that's our hypothesis. So remember, hypothesis is the P part. And Q be a number divisible by 6. So that would be our conclusion. So we're thinking if then for hypothesis and conclusion. All right, letter A, right? And so this is the notation if P then Q. All right, and I think yesterday I wrote it with one arrow. Okay, but if P then Q. So I'm going to write if a number is divisible by 3, then a number is divisible by 6. Or we could say then it is divisible by 6. I probably don't need to repeat the word number twice. Okay, if a number is divisible by 3, then I'll probably just say then it is divisible by 6. It is divisible by 6. Okay, so if a number is divisible by 3, then it is divisible by 6. If P, then Q. Okay, letter B, right? Q, then P. So Q, then P, I want you to recognize that's the converse. We're switching it. So then I'll say if a number is divisible by 6, then it is divisible by 3. If a number is divisible by 6, it is divisible by 3. By 3. Okay, so let's actually, let's read C and then we're going to go back to A and B. Okay, is P, now this symbol is the biconditional symbol. So I'm going to, over to the side, that is the biconditional. Okay, so we can interpret that as you can read it forward and backwards and it says the same thing. So is that true? All right, so in order to even have a biconditional from the other section, both the converse and inverse must be true. So like a definition, like the perpendicular line definition. So let's come back up here. Is part A true? If a number is divisible by 3, then it is divisible by 6. I mean, so you can think of some examples like if it's divisible by 3. 3 is divisible by 3. So let's say we're taking 3. Is 3 divisible by 6? No, it is not. Because when we're talking about divisibility rules, we are talking about when you divide the numbers, you get an integer, you get a whole number. So 3, when you divide by 6, you get a fraction. It's 1/2. So this is false. What about this one? If a number is divisible by 6, it is divisible by 3. So 6 is divisible by 6. 6 is divisible by 3. 12. 12 is divisible by 3. 18. Yeah, so this is true. So right here, I cannot even write a biconditional. Okay, so is the biconditional true? No. I'm going to say here, cannot write biconditional. Okay, so that's one thing that we'll practice a little bit more, that you must have a true converse and conditional in order to even move on to the biconditional. Okay, I want you to do D and E. So go back to if P then Q, and I want you to write its contrapositive and its inverse. Okay, so why don't you pause if you need to look back, take a look at that. Otherwise, go ahead and write your two statements down. And when you come back, I'll have my statements written down. Okay, contrapositive. Switch them and make them both not. If a number is not divisible by 6, then it is not divisible by 3. And then the inverse goes back to the original if-then and then just makes them not. If a number is not divisible by 3, then it is not divisible by 6. So let's actually add the notation for contrapositive and inverse with P's and Q's, just to kind of cover everything. So contrapositive is when we switch them and they're both not. So it would be written as not Q and then leads to where the arrow would be not P. Okay, and then inverse, we just kind of flip these around. So not P and not Q. So I want you to kind of work on both the notation and the terms, inverse, contrapositive, that type of thing. That way, the notation is supposed to help you write the sentence a little easier. Okay, let's stop the video here. We'll come back to the logic laws and hopefully wrap it up in one more video.